Hello, grade 8. This is Miss Mary. Hope everything is okay. Today we will start the fourth quarter, and this is the first video. In this video, we will chemical bonding. So let's start. Here, let's make a quick revision about what means atom. If you remember that atom is the smallest building unit of matter, or the smallest particle in matter, that shares with chemical reactions. When we speak about chemical reactions, atoms, they join together or they bond together to form bonds, and this is our lesson for today. In the atom, the number of electrons equal the number of protons, if you remember, and we call this atomic number. So the atomic number, as we said before, is the number of protons in the atom, and as we know that protons and electrons are equal. Here, do you remember this model for who? Yeah, which one? Yes, this one for Bohr scientists. So chemical bonding, what means chemical bonding? Is the joining of atoms to form new substances. When two atoms they join together, they form new substance. Like here, the properties of new substance are different from the properties of the elements. Like when we have here two hydrogen atom and two oxygen atom, they join together to make the water. And in this case, they make new substance which is totally different from hydrogen alone and oxygen alone. So this means what means chemical bonding. So the bond here between hydrogen and hydrogen alone, the bond here break down, and the bond between oxygen break down to form new bonds between hydrogen and oxygen. And water is totally different from hydrogen and from oxygen. Okay. The interaction that holds the two atoms together, this interaction, we call this bond. So this part from the compound is called bond. So a bond that holds two or more atoms together, we call it chemical bond. Again, so what is the chemical bond? The chemical bond, interaction that holds two atoms together. Electrons arrangement in the atom. If you remember, we said electrons, they are found inside energy levels. In this atom, we have three energy levels. Here is the nucleus. The first energy levels carries 2 electrons only. The second energy levels carries 8 electrons. If we count them, we will find them 8. Also, the third level carries 8 electrons as well. The first energy level is the closest to the nucleus, and it can hold up, as we said, until it carries 2 electrons, and this is the maximum number it carries. We cannot put more than 2 electrons in the in the first shell. Electrons will begin filling the second energy level. So first we fill the first level, and then the second level full with 8 electrons. It can't hold more than 8 electrons. So if we will distribute 17 electrons on these 3 energy levels, the first energy level will take 2, the second will take 8, so 2 plus 8, 10, and outer level will take only 7 electrons, or what left from the 17 electrons to be 7. Okay, so now we know how to arrange electrons in the atom. Most atoms, they tend to have 8 electrons in the outer shell. They all the time want to have 8 electrons in the outer shell, or 0 electrons. They can have 0 or 8, and in the two cases we can call that the atom is stable. Outer level electrons and bonding. Not all electrons in the atom make chemical bonds. When the atoms combine together to form bonds between them, only the outer electrons they share in the bonds, not the inner ones. Not the first and the second levels electrons, they don't participate in the chemical bonds, but the outer shell, the electrons in the outer shell only. So most atoms form bonds using only the outermost energy level electrons, and they are called valency electron. We call them valency electron, and they only participate in the chemical bonds. The valency electron for the two atoms here, we have the oxygen, we have the sodium. The oxygen has total electrons 8, so the inner shell will take 2. And 8 minus 2, 6, so the outer shell will take how many? 6 electrons. 1, 2, 3, 4, 5, 6. So here the oxygen has 6 valency electrons. Understand? Right, let's go to the other side for sodium. The sodium has 11 electrons. As we said, the first shell will carry 2, the second shell will carry 8, and 2 plus 8, 10, so how many left? 1, so we will keep the 1 on the outer shell. So sodium atom has 1 valency electron. So again, valency electrons are electrons in the outermost shell, or the outermost energy level. The elements can be classified according to their properties and electronic structure. We divide elements into 3 groups: metals, non-metals, and noble gases. Let's see first what are the metals. As you remember, here is a periodic table. We said that all the blue color for metals and the yellow for non-metals. The last group here, group 18, we call them noble gases or inert gases. They are very stable. Their outer shell is complete. We will speak about them later. So let's start here. Atoms of elements in group 1 and 2, they have the same number of valency as the number of groups. So the number of group determine the valency for these elements. So all these elements have valency electron 1. Okay. The valency 1 here. All these elements, they have valency 2, or they have 2 electrons in their outer shell. From group 3 to 12, they don't have clear rule because the atoms here, they don't have rule to their valency. It doesn't. So this group, they don't have 3 valency in their outer shell or 3 valency electrons. No, they don't follow regular pattern. They are different. And then we will go to group 13. Group 13, in this group, actually we will remove 10, and this will be the valency. Yeah, so if this one has 13, the valency, the group 13, remove 10, so it will be 3. So all of these elements, they have valency 3. Okay? So in this group also, remove 10. So when you remove 10, we will have 4. So all of these elements, they have valency 4. Here, the nitrogen group here, this group, they will have how many valency electrons? Yes, they will have 5. So for all these electrons, for all these groups, we will remove 10 from the number of the group. Here, in this group, they have 17. Group 17, so we will remove 10, so they will have valency 7. Here the noble gases, remove 10, so they will have valency 8, and they 8, it means that they have a complete set of electrons in the outer shell, so they are very stable. Except helium. Helium doesn't have doesn't have 8 valency electrons. It has only 2 on the outer shell, because helium has only 2 electrons. So when you distribute 2 electrons, the first level will take them, so it has only 1 level. It has only 2 valence electron. This is the only exception for the noble gases, but neon, argon, krypton, xenon, they all have 8 valency electron in their outer shell. Metals. As we know that metals are elements which have less than 4 electrons in their outermost energy level. All metals have less than 4. They can have 1, they can have 2, 3. They don't have 4, they have less than 4 electrons. Properties of metals: they are solid except mercury. Mercury is the only metal that is liquid at room temperature, which is only metallic element, liquid metallic element. They have metallic luster, they are shiny, it means. They are good conductors of heat and electricity. Usually metals, they tend to lose electrons because 1 or 2 or 3 electrons, they are easier to lose them than gaining 6 or 7 electrons to complete the outer shell with 8. As we said before, that all atoms want to complete their outer shell with 8 or to have 0 electrons in the outer shell, and in these two cases the atom will be stable. So metals, because they have 1 or 2 or 3 electrons in their outer shell, so it's easier for them to lose these electrons, and in this case they lose all the electrons in the outer shell and they stay with the previous shell, which has 8 electrons. They are malleable and ductile. Example for metal is sodium. Sodium has atomic number 11 and atomic mass 23. If we will distribute the electrons of sodium, as we said, this is a nucleus, has 11 protons and 12 neutrons. In the outer shell, the first level has 2 electrons, the second level will have 8, and the outer shell will have 1 electron. In this case, the sodium will lose 1 electron, the valence electron, the outer shell, and will have only 2 shells, the first one 2 and the second one will have 8 electrons. And in this case, sodium is very stable. It will be better for sodium to lose 1 electron. So metals, as we said, they lose electrons. During the chemical reaction, atom sodium loses 1 electron and change into positive ion. In this case, we call it positive ion. Someone will ask me how positive ion, because here the protons positive, they are 11, and we have here 10 electrons negative. So which one is more, the protons or the electrons? Yes, the protons are more, and that's why the overall charge of the atom will be positive. And now it will be ion. We call it positive ion. So when atoms lose electrons, they change to positive ions, which carries 1 positive charge. So if we will compare between the neutral sodium, when it has the same number of protons and the same number of electrons when they are equal, and here we will compare the positive ion. Let's see. It contains 11 electrons, 11 protons, and 12 neutrons. So if you look here, you will find that the number of electrons, the negative, equals to the number of protons, which is positive. So when they are equal, we call that this atom is neutral, the positive equal to the negative. But here it contains the positive sodium ion. It has 10 electrons because it lost 1, and 11 protons and 12 neutrons. So here the electrons are less than protons. Protons are more with 1. So here we call this positive ion. Non-metals, here first let's know what it means, non-metal. As we said, they are elements which have more than 4 electrons in the outermost energy. They are solids and gases except bromine, Br, which is only liquid non-metallic elements. Most of we have only in the periodic table, we have only 2 elements liquid: the bromine, which is non-metal liquid, and the mercury, which is metal liquid. They have no luster, they are not shiny, so most of them they are dull. They are bad conductors of heat and electricity. They don't conduct electricity well, except the graphite or carbon. They use them in batteries. They are not malleable and ductile. They are brittle or easily break down. we have example chlorine 17, atomic number 17, and atomic mass 35, 17 for electrons. So let's see now how we can distribute the 17 electrons in the outer and the energy levels of chlorine. Here, this is a nucleus, has 17 protons and 18 neutrons. In the first shell, it will be 2. Second shell will be 8, and the third shell will be 7. So all of them together, 17. Okay, as we said, the first level carries only 2. Second level carries till 8, and the last one will carry 7, and all of them will be 17 electrons. The chlorine needs 1 electron to have 8 electrons in the outer shell. Here the chlorine will gain 1 electron, and in this case will it change to first level 2 like it was, and here also 8, and the outer shell here will be 8, and in this case chlorine will be stable because it has valency 8. So in this case, during the chemical reaction, chlorine atom gains 1 electron and it changes into negative ion, which carries 1 negative. Here, after gaining 1 electrons, we have 1 more electrons. We have 18 electrons with negative charge and 17 protons with positive charge. So which one is more? Yes, the electrons are more, so the overall charge here is 1, negative 1. So let's compare here between the neutral chlorine and the positive chlorine. Here it contains 17 electrons, 17 protons, and 18 neutrons. And the positive chlorine ion, it contains 18 electrons, 17 protons, and 18 neutrons. So here they are equal, so it's neutral. Here electrons are more than protons with 1, so the overall charge will be negative 1. Filling outermost energy level, here sulfur, an atom of sulfur has 6 valency electrons. The outer shell has 6 electrons, and this is the valency electrons. It can have 8 valency electrons by sharing 2 electrons or gaining 2 electrons from other atoms. So to complete the 6 electrons to 8, we need 2 more. Sulfur needs 2 more electrons to complete the outer shell into 8. Let's see the magnesium. Magnesium, an atom of magnesium has 2 valence electron. Here is 1 electron and here 1 electron. So the outer shell has 2 valence electron. So what the case here? Do you think magnesium will take 6 electrons from outside to complete the outer shell to have 8 electrons, or will easily lose the 2 electrons and stay with the inner shell which has 8 electrons? Yes, it will lose the 2 electrons. An atom of magnesium has 2 valence electrons. It can have a full outer energy level by losing the 2 electrons and stay with the second energy level, becomes the outermost energy level and contains 8 electrons. So in this case, the magnesium will lose the 2 electrons and will stay with the inner shell, this one which has 8 electrons, and by this way the magnesium will be stable. So this was everything for today. In the next video we will complete the lesson. So see you soon and take care of yourselves. Bye bye.